Now it's working. So, Mark Wood here. I wanted to talk a little bit about a project that I have going on. And that project is a control line model airplane that I've been flying for a while. And I did a modification the other day that is worth sharing. What that modification is I added spades to my flaps. Now, spades are something that are commonly used on full-size aircraft, aerobatic airplanes, and the purpose of the spades are to reduce the control forces that are experienced in the airplanes. So with the aerobatic airplanes, they like to be able to roll very quickly and precisely, which means that they would like to have light control forces, and whenever you have a very big surface, light control forces don't come along with them. The control surface creates what we call a hinge moment, and that hinge moment is a function of the deflection of the surface and where the hinge is located in that control surface. We can adjust some of those on an existing airplane by the implementation of small flying surfaces we call spades. And let me show you the spade on my airplane here. And that's this spade right here. This is the surface, this thing. That's the spade. You see the tufts. I've got some videos that you can see on my channel of where I've been testing the airplane and taking pictures, videos of the airplane in flight. I have a camera that I can put on here, a camera that I can put on here on the back, and I may end up doing some other locations on the airplane because it's kind of entertaining to see the airplane going around maneuvers and around the corners and stuff, especially for those people that are involved in the hobby. So you can see what happens here when I move my controls. The spade, what it does is it adds some area forward of the hinge line. Here's the hinge line. So when we deflect a surface, a control, like the elevator right here, it has no counterbalance on it, and that's basically what this surface is a counterbalance. You sometimes see the end of the wing will have a projection out here. That's called a control horn or a horn balance. That was particularly prevalent in the World War I airplanes, and the purpose of those is exactly the same purpose as these right here. And so what happens is when the control surface is deflected, the center of pressure on this control surface is somewhere out about right here. And so it pushes this back down. And that's what creates what we call the hinge moment. So that lift acting through this arm right here, the product of those two is a moment. So the basis of the spade is that it adds some area in front of the hinge line, which means it puts some negative moment for deflection. It puts some negative moment in and helps counterbalance the moment that's generated from the deflection of the surface. So there's a couple of things that are desirable in the spade surface itself. One of them is that it behaves in a very predictable manner. And in order to do that, what I've done with this particular surface is I have shaped it in the plan form of a delta. A delta wing plan form gets the majority of its lift from the vortex that rolls up off of this edge right here, and it swirls up on top of the surface or on the bottom, if it's deflected the other way, but it rolls up and it creates the low pressure zone over the surface, and that's what creates the aerodynamic forces, the lift. It also creates a lot of drag, but that's okay for the purpose of this spade surface. And so the other feature is that it's not a very high aspect ratio device, and we don't want a high aspect ratio device because this, if we did, it would behave more like a wing. And even though it is a wing of sorts, we don't want it to behave like a normal wing. You know, a normal wing, when it increases its angle of attack like this, somewhere between 15 and 20 degrees, it will stall, and the lift stops increasing with angle. That is not a characteristic we want of this surface that's flying out in front of our flaps. We want it to continue to make lift in the direction that it's moving. And so that's why we like this delta plan form. Now, you know, it could come way out front here, but the problem with that is that you see that eventually it will collide with the wing surface. Moves in, it goes like this, and that's why this has this truncated delta shape to it. It's specifically because of the interference right here that happens in here. And this is a shape that I've used on a number of full-size airplanes. I saw some pieces over in the corner of previous tests that we use, and I think there's a general rule. You could say that the aspect ratio should be less than 2 to 1, so no more than 2 times in span to 1 time the overall chord length here is a pretty good rule of thumb. There are airplanes that have square section spades, and they tend to be like just a 1-to-1 ratio, and they tend to work. But I have found that this delta plan form really is fairly predictable in its behavior. So the trailing edge of this spade lines up with the hinge line of the airplane, of the flap, and so the support is designed such that whenever the control surface deflects, it allows that spade to move. Now that spade gets its moment is generated by the combination of lift and drag. So you see that there's a vertical separation in this device, and the drag component contributes this way, creates a moment, and the lift component creates a moment. So when I sized this, the way I sized it was that I calculated the area of the flap, and knowing that if the flap were a free surface and it was hinged at 25% thereabouts, it would have a neutral balance. I calculated my spade to be less than 10%. This particular spade is about 7%, just a little bit less than 7% of the area of the flap. I could make this bigger, and I probably will. I'll probably try one with maybe another, I don't know, 3/8 of an inch more span on either side. I don't want to go very far because when you start doing that, it starts behaving more like a wing. I could put another one on out here, you know, somewhere out towards the tip. If I did that, it wouldn't be as big as the one that's here. It'd be maybe half the size. But the flying results of this particular configuration was quite good. I was very impressed by the amount of change that this particular modification made. A lot of things that you do don't make a very big change in the behavior of the airplane. This particular change was significant enough to be very, very noticeable. The benefits of having lower control forces, control moments, are things like when we're flying overhead. The more overhead you are, the less line tension you have. The less line tension you have, it reduces your ability to deflect the controls, translating into lower ability to control the airplane. And when I was flying the other day, I was able to do some very interesting maneuvers, some that I call like stop sign loops, stop line 8s. The triangle figures are real easy. I did a few things that are not real standard. Anyway, the results are very good. I plan on flying this again probably tomorrow. I bought a new camera, a new replacement one of these cameras. You know, this right here, this GoPro. And I'll take it out and fly it tomorrow. And I'm going to put the cameras on, put the cameras back on, so I can watch the spades and see what they're doing, see if they're doing anything, anything funny. And I'll post that video. That'll be online. So anyway, I just wanted to give you a look at the spades that I made. Have an awesome day.